In this video, we will talk about mitigating these spoofing attacks. DHCP snooping is a network security feature, guys, used on managed switches to protect against unauthorized or malicious DHCP servers and to prevent various DHCP-related attacks such as DHCP spoofing or DHCP starvation. So by validating DHCP messages and maintaining a binding table of IP to MAC address mappings, DHCP snooping helps to ensure that only authorized DHCP servers are allowed to provide IP configurations to the clients. So how it works? First of all, DHCP snooping relies on ports to determine which DHCP servers are trusted. So trusted ports are typically those that connect to legitimate DHCP servers. So DHCP messages received on these trusted ports are not filtered. And also we have untrusted ports. Those are the ports that connect to end user devices or potential attackers are considered untrusted. So DHCP messages received on these ports are subject to validation. And then DHCP snooping builds a DHCP binding table by reviewing the DHCP messages, and this table records the association between IP addresses, MAC addresses, VLANs, and switch ports of DHCP clients. So the binding table is dynamically updated as clients receive the IP addresses from the DHCP server. And DHCP snooping also validates the DHCP messages. So when a DHCP client sends request or receives an offer, DHCP snooping checks if the message comes from a trusted port and whether the DHCP server is authorized. So if a DHCP message comes from untrusted port or if the message does not match the expected binding information, it is dropped or filtered out. And this is how I'm doing the configuration for DHCP snooping. First of all, I need to enable the DHCP snooping globally. How I'm doing it? By typing IP DHCP snooping command. And then I'm going ahead and enabling DHCP snooping on specific VLANs that I want to protect DHCP traffic. Then I'm going ahead and typing IP DHCP snooping information option. So that is a feature which enhances the DHCP snooping capability by allowing the switch to include additional information in the DHCP packets that it forwards. And then I'm going into the interface mode anymore and typing IP DHCP snooping limit rate, and I'm giving a rate. So that defines the number of DHCP packets that can be accepted in the port at the moment. And lastly, I'm going ahead and defining my trust configuration. So this trust configuration should be done for the ports where a DHCP server connected to or any other trunk ports. So we have IP source guard as well. That is a feature used on switches to prevent IP address spoofing by ensuring that only valid IP to MAC address bindings can communicate on a switch port. So this is commonly used in environments where devices need to be prevented from using IP addresses other than those assigned by the DHCP server or configured statically. So how it works? First of all, IP source guard relies on IP to MAC address bindings to verify the legitimacy of the source IP address of the packets. And these bindings are typically learned from the DHCP snooping or can be manually configured. Then, when DHCP snooping is enabled, the switch builds a DHCP binding table that records the IP to MAC address mappings of the devices that have obtained their IP addresses from a DHCP server, and IP source guard uses this table to enforce security by allowing only traffic from IP addresses that match the bindings. So you can also manually configure IP to MAC address bindings on the switch, and this is useful for devices with statically assigned IP addresses. So there are two types of filters in SourceGuard. The first one is source IP address filter. Here the IP traffic is filtered based on the IP address of the source, and only IP addresses matching the addresses in the IP source binding lists are allowed. And the second filter type is source IP and the MAC address filter. Here IP traffic is filtered based on the IP and MAC address of the source. So only IP addresses that match the addresses in the IP and MAC source binding lists are allowed. So the configuration for IP source guard is very much straightforward. You are going into the interface mode and you are basically typing IP verify source and IP verify source port security. If you just want to verify this configuration, the command is show IP verify source. It will show you all of the bindings. And we have the dynamic ARP inspection. Dynamic ARP inspection, guys, that is a security feature designed to prevent ARP spoofing attacks on a network. So ARP spoofing involves an attacker sending fake ARP messages to associate their MAC address with the IP address of another device, potentially allowing them to intercept or redirect traffic meant to that device. So dynamic ARP inspection helps protect against such attacks by validating the ARP requests and responses based on a trusted database of IP to MAC address mappings. So again, it relies on DHCP snooping to build this database, or also can use static ARP entries if configured manually. So how it works? When DHCP snooping is enabled, guys, the switch listens to DHCP traffic to build a DHCP snooping binding table, as I told you before, which maps IP addresses to MAC addresses. And when an ARP request or reply is received, dynamic ARP inspection checks the ARP packet against the binding table to ensure that the IP to MAC address mapping is valid. If an ARP packet does not match the expected IP to MAC mapping in the binding table, it is dropped, which prevents the attacker from poisoning the ARP cache of other devices. On the screen you are seeing a sample topology defining how the dynamic ARP inspection works. Okay, so we have our DHCP snooping database. Basically it says the IP address of this server is binded with the MAC address of this server. If an attacker comes in the picture and tries to pretend as the server by assigning the same IP address to its PC and generate some ARP traffic, this traffic will be denied because the MAC address of the attacker will be different from the server's MAC address. And this is how dynamic ARP inspection configuration looks like. First of all, there is a configuration for DHCP snooping in config mode, and in config mode you need to define your IP ARP inspection and specify for which VLAN you need to perform your ARP inspection. Okay, then you are going into the interface mode, same like you are configuring a DHCP snooping, and you need to define your trust ports for dynamic ARP inspection as well. So that's it. Okay guys, we are coming to end of this section as well, and thank you so much for listening to me.